So as you know, because you clicked on this particular topic, gear-driven orbital versus random orbital. So these two different polishers, we are going to go over the specific characteristic and features of each of these polishers. And our objective for this webinar is to educate you and make you aware of the specific capabilities of each of these tools so that you can make an educated decision for yourself on which one of these tools is the best for you and your business and your hobby. Before we dive into the actual content, we want to get your opinion. So this is where you move your mouse and click on your keyboard there. We want to find out from you some information about this topic before we dive into our presentation. So to do this, I'm going to turn this over to Dylan, who will ask you some survey questions.
Thanks, Jason. And apologies to anybody watching out there on Facebook. Looks like there's a little bit of a technical problem with that, and you may not be getting the feed at the moment, or maybe it's slightly delayed. But and the voting for this poll will not be live on Facebook. So just the people participating in the webinar will be seeing this. So let's start with launching the poll here for you. And so simply just place your votes. What we're wanting to know is, which of the tools do you use most? Do you use a random orbital, a gear-driven, or are you a heavy rotary user? Second question of the poll is, which one has the higher defect removing capacity? So which tool do you think has better defect removal rate, gear-driven or random orbital? Which tool do you think finishes better? Which one of those tools do you think has the better finishing? Lots of votes coming in. And then lastly, which one do you think is more effective at doing edge work, so the outer edges of panels and things? And so no wrong answers. We want your opinions because it'll just be interesting to see. Wow, you guys are voting fast. We're up to 75 votes. We'll leave it open for just a little bit longer and get more of you guys' votes in on this. Very cool. All right, 100 votes, 105. Wow, you guys just keep on going. I love it. All right, that's about a minute, so we'll go ahead and we're going to close it there, and we're going to share this with you guys so you can see it. So just to recap, which type of tool do you use most? Looks like, well, 78% of you guys are random orbital users. Got 12% of you on gear-driven and 11% on rotary, so heavy random orbital audience. Your guys' opinion, closer here, which has the higher defect removal capability? So gear-driven with an edge at 69% versus 31%. And which one has the better finishing capability? We flip-flop that, or we got 85% of you believe it's the random orbital. And then the most effective at edge work, very tight race there. 59% of you say it's the gear-driven and 41% say that it is the random orbital. So awesome. Well, I'll turn it back over to you, Jason. So that gives us kind of a little bit of a window into what everybody's thinking.
Yeah, fantastic. Thank you for your sharing there on those questions. It's certainly enlightening to see your answers to those questions. And this information we're about to present is going to be very helpful for you based on your answers. So let's go into comparing these in a very, very basic way before we get into a deep dive on each of these. These two tools are both classified as dual action orbitals. So meaning that when you pull the trigger, the tool generates two movements on the paint simultaneously. So let's look at each of these movements. So the rotation, and both of these tools do have a rotational part of the movement. Now the gear-driven orbital, when you manually turn the pad, you turn the gears, turn the motor. That means the rotation is forced. And by contrast, the random orbital tools, and this is true of all random orbital tools, not just BigFoot, but if you're able to rotate the pad manually and it free spins, then that is a dual action random orbital. Now, they both have an orbit that is both forced, so when you pull the trigger, the tool generates an orbit automatically. Now, these two actions that each of these tools make each tool has what we call a dominating movement. For example, the gear-driven orbital generates a rotation and an orbit, but what is doing the work on the paint mostly is the rotation. So when you pull the trigger and you actuate this tool on the paint, the rotation is doing most of the work on the paint. The random orbital is the opposite, actually. So when you apply this tool to the paint, the dominating movement, especially with large orbit random orbital polishers, is the orbit. The orbit is doing most of the work for that type tool. The pattern that the tool actually makes on the paint is a difference between these two tools as well. So the pattern that a gear-driven orbital makes is very predictable. You can draw it. It's a very, very predictable pattern that is the same no matter where you are on the car. By contrast, the random orbital BigFoot polisher has a random pattern, meaning that the actual pattern changes based on input from the user. So the orbits, the rate of the orbits, the rate of the rotation, based on technique changes, and it changes the pattern actually on the paint. So didn't you, it's exciting for you to know that you have the control of that on this tool, so you can actually change the pattern as you see fit based on what you're trying to do. So those are a summary of the basic features of both of these tools. We will now go into our deep dive into comparing the characteristics of these tools. We are going to look at these tools from these 6 different performance criteria. Starting with the potential cutting power, we're going to compare the cutting power of these tools. What we mean by this is the ability of the tool to remove defects on the paint, which obviously they both do, but there's some interesting differences between these tools. So we will go now to our team Random Orbital, and Todd, take it away. Tell us about the cutting power of Random Orbital.
Absolutely. Thank you, Jason. One thing before I get started, and just to frame this, is RUPES is one of the oldest manufacturers and the originator of the gear-driven movement, the originator of the BigFoot random orbital movement, that large diameter. So we really have a good technical explanation and understanding of these tools. The debate format between me and my colleague Fabrizio is done to make it fun and interesting, but the idea here is to give you some educational component. With all of that said, I'm very excited to be chosen to represent Team Random Orbital. And there is a big misconception amongst users, and we saw that a little bit in the poll, that the Random Orbital is a polishing tool, it's a finishing tool, and it's not a corrective tool. Well, some of the best detailers in the world and body shop technicians everywhere have found that a good BigFoot random orbital polishing system, that is the combination of the large diameter orbital movement, the pads and the compounds, allow them to remove up to 1500 grade sand scratches from most painted surfaces. If you need more correction than this, then you should be sanding. So to say that the random orbital lacks any cutting performance, particularly if you size the tool to the body shape panel and curvature, is simply incorrect. The random orbital, the BigFoot random orbital, is an excellent cutting tool.
Awesome. Thank you, Todd, for that description of the cutting power. We'll go to Fabrizio to hear about gear-driven orbital cutting power.
Thank you, Jason, and hello, everyone. So I have 1 minute to tell you why you can't underestimate the ability of the gear-driven machine to remove defects. And the reason is simple. We have 2 movements, we have a rotation, we have orbit. They always happen together. And the rotation, which is the same we find in a rotary tool, is able to remove the defects. But these 2 movements, they always happen, no matter what's the shape of the panel, no matter what's the technique you're using. We always have rotation and orbit happening together. This is why this machine is very, very good at removing defects on every shape of the panel, but also on different materials like very hard surfaces or gel coat, oxidized gel coat. So materials that are very hard and where you need to be aggressive and to be able to remove the defects. Can I remove P1500 grit sanding marks? Yes, of course I can. So this is a machine that will allow you to do quick jobs and very well done.
Excellent. Thank you both. Very good points on both sides of this debate. And I want to clarify that this evaluation of the cutting power of these tools is a very difficult thing to come to a conclusion because the reality of random orbital, the BigFoot random orbital polisher, is that based on the skill set and the experience of the user, the BigFoot random orbital actually, the cutting power is a variable. And there are some of us who have our skills so well developed that we get rotary-like defect removal. So the cutting power of the random orbital is a bit of a variable. To answer this and to conclude about the cutting power comparison between these two tools, we will make the assumption that we are talking about the average user of these tools. So average knowledge, average experience, average skill set. If they picked up these two tools, what would the expectation of cutting power be? So we will give it a very, very slight advantage on cutting power to Team Gear-Driven Orbital. And again, it's very, very, very slight, and there is the potential, especially on flat panels, for the random orbital to cut significantly more. Now, we also want to take the opportunity to give you a peak performance adjustment tip. So based on the use of these two tools, what can you do as the user to immediately get peak performance on cutting power? With the gear-driven orbital, there's one thing that you can do with the gear-driven orbital that will immediately increase your cutting power, and that is simply to increase the downward pressure on the paint. So you take the gear-driven orbital, push down, it will cut more. Now with the random orbital, the one thing you can do to immediately improve cutting power is to slow down your arm speed, the rate that you move this tool across the paint. If you slow down your arm speed, you will immediately get more defects removed. So there's our peak performance adjustment tip. And we will go to the next performance criteria, which is called the potential finishing quality. This is the ability of these tools to finish out defect-free, clear and glossy finish, no swirl marks, no holograms. That's what we're talking about with finish quality. So evaluating the finish quality for Team Random Orbital, we will go back to Todd and hear from him.
Thank you again, Jason. One of the dirty secrets of polishing paint or any solid surface is that you always leave a mark. And you control this mark by how fine the pad is, how fine the abrasive is, and there's actually a ton of variables. But that mark always is placed in the pattern that the pad is moved across the paint. So anytime you have a spinning motion, that's your dominant movement, rotary, gear-driven, you're going to create the potential for a repeating mark that your eyes see. Random orbital, because the rotation is random and ever-changing, it's a constant crosshatch of that mark, so the mark covers itself. It's random. You can't see it. So this gives the random orbital and the BigFoot random orbital polishing system the ability to create a swirl-free high-gloss finish on the most delicate paint surfaces. And one thing that we've seen a lot recently is with the new DA Blue foam coarse pad and the DA BigFoot compound, which is both aggressive products, people are producing an excellent finish in just one step because of the movement of the tool. The random orbital, in terms of finish quality, it just can't be beat.
All right, thank you, Todd. Now we will go to Fabrizio to hear from him about gear-driven orbital finishing.
Thank you, Jason. So which one is giving a better finish between random orbital and gear-driven? I want you to take a look to the video that is running in the slide. And you can see the very good finish that we have in this video, but watch how this guy is working. This guy is doing everything that we do not recommend on polishing. He's pushing very hard, using the edge, and nevertheless, the quality that you get is very good. That's the big advantage of the gear-driven. We have a movement which is a dual action. Probably we don't, or definitely we don't have the random element that the Team Random-orbital has, and that makes our movement more predictable and so easier to leave some haze or some minor defects. But we have a dual action. The movement is so complicated that all these minor defects, very small swirl marks, or just a few of holograms, they can be barely visible with our eyes because the movement is so complicated that our eyes is not able to detect them. So the finish you can get with our tool is very good, and you can get it very easily.
Excellent points, both of you. And I think we all will agree that both of these polishers have fantastic finishing ability. But again, we're looking at this from the perspective of the average user with the average skills, average knowledge. So what we'll do here is we'll give this to the Random-orbital as a slightly better finishing tool. And basically because of that built-in engineering feature of this free spinning rotation and its ability to actually leave that random pattern on the finish that is less visible for the eye to see. We'll add our peak performance adjustment tip here. If you want to improve the finishing ability of the gear-driven polisher, you simply change the compound and pad combination and you will immediately have better finishing. So simply switching up your combo to a finer or ultra fine combo, immediately you get better finishing. Now, the other recommendation we can have on the Random-orbital to improve finishing ability is to make adjustments in your application technique. So things like downward pressure, arm speed, tool speed, those things will immediately have an impact on its finishing ability, as well as changing the combo. But the technique immediately on the fly as you're working on the paint can improve your finishing ability. So with that, we have talked about cutting, we've talked about finishing. We will now discuss efficiency. Efficiency has to do with time and steps, the total start to finish of the job. So we will start with Team Random-orbital. Tell us about efficiency.
You know, this is a great subject for Team Random-orbital to talk about, Jason. One thing I want the audience that's watching live on Zoom or maybe watching a replay on YouTube, for example, on the RUPES channel, to understand is that we've already done the science on this. This system has been tested independently by a huge dealership chain, and they found that the Random-orbital was 22 to 23% faster than any other system on the market. That's the BigFoot Random-orbital system. So we already have the answer. And the reason goes back to the previous 2 points. We can remove a 1500 grit scratch and we produce a superior finish. This means the combination of cutting and finishing that's built into the Random-orbital movement allows us the highest potential to have a one-step polishing solution. Random-orbitals don't have that edge velocity that you see from a spinning tool, so there's less splatter and less sling and less cleanup, again, saving time. So this is really 2 of the ways that the Random-orbital is very, very efficient, and something that we're going to dive into the safety and ease of use factors is that we also have the lowest risk of damaging the panel. So nothing takes more time than redoing work or fixing damage. So the Random-orbital, by its design, and particularly when compared or paired with the correct components, is the most efficient polishing process that is available.
Awesome. I certainly agree with those points. Let's hear from Fabrizio about efficiency with the gear-driven orbital.
Yes, Jason, you correctly said what's efficiency. Efficiency is how long do I take to make the job? And how long does it take to make the job if I'm using a whole, just one tool to do the whole car? I can use a gear-driven machine to work on the roof and on the bonnet and on the doors, just like I can use the same tool on the bumper and on the edges. I don't need to downsize, thing that I need to do when I'm working with a random orbital machine. I need two different tools to do the whole job. In this case, I can do one job, the whole job with just one tool. And the second element is, can I do just a one-step process? Of course I can. I have a dual action. I have the orbit helping me to get a good finish, even though I'm using wool, even though I'm using cutting compounds. I can have a very good finish. Shall I have the same probabilities to make a one-step job like with the random orbital? Probably not, but the difference is very low, it's very minimal. So this is a great tool to save time and to save money, because time is money.
Excellent. Great point, Fabrizio, especially when you talk about the efficiency with a one-tool approach with the gear-driven orbital. So the one deficiency, potential deficiency with the gear-driven orbital as far as efficiency goes is on the area of soft or delicate paints. This tool can potentially leave a pad mark, which requires a second step. So that's kind of a ding on the efficiency side for gear-driven orbital. But I agree, Fabrizio, with all your points that it is much more efficient than some other methods of polishing. However, for this one, we are going to give the edge on efficiency to random orbital simply because all things considered, including skill and technique, the ability to do one-step paint correction, the random orbital simply has the most potential to get that result. Our peak performance adjustment tip for efficiency is the same for both of these tools. And in our training programs, we stress this and we focus on this, and that is doing a proper test spot. This means testing the combination of the tool, the compound, and the pad, and a technique on the paint to see how that paint responds. And the goal of the test spot is to identify what compound and pad combination will give us the result of one-step paint correction, which is the most efficient way to polish any car. So in both cases, if you do a proper test spot with these tools, you can dial in the best combination and get that job done in the most efficient way possible. All right, going from efficiency, now we will talk about edge work. Edge work is defined as the outside 2 inches of every panel on every car. It's the curves, the contours, the tight areas, and the detail areas that we slow down and kind of nitpick. This is all called edge work. These tools come at edge work a different way, and I'm looking forward to this presentation about edge work. So we'll start with Team Random Orbital.
The Random Orbital tool has one huge advantage when it comes to edge work, and that is the safety, which we're going to save that for the next point. But the ability for the Random Orbital to reduce burns and marks allows us to downsize the tool and go to a number of places that it's just not safe for other styles of tool that rely on edge speed. So by being the safest choice, we're able to take edges and tight areas, really concave curves to a really high gloss without worrying about burning or damaging the paint. And that's a significant advantage that you can't say about any other style of tool. You do have to downsize the tool to maintain efficiency. So you can see in the video that's playing on the screen, we're using the BigFoot Nano with hybrid technology to polish the door handle, but nothing is going to give us that level of ability to downsize the tool to that panel and get an excellent result.
Awesome. So with that, we'll hear from Fabrizio about the edge work capability of the gear-driven tool.
Yes, Jason, the forced rotation, the gear-driven movement is definitely the most suitable for small areas. Why? Because, yeah, we have a dual action. We have the orbit helping us to get a better finish, but still we have mainly a rotary motion. And how comes that even if I have the orbit, I can work pretty well in tight areas because the orbit is small? How comes? So the question is, okay, but how can I cut if I have a small orbit? Yeah, but we're not random orbital. We are gear driven. It means that most of the job of the cutting job is made by the rotation, and the 5 millimeters are good for helping me to get a better finish, but they're not creating any problem when I work in very small areas, just like in the video next to the front lights or where I have the bumper. I have a perfect control of the action I'm doing, and I'm not losing any kind of cutting performances.
Excellent. Yeah, that's a strong argument in favor of the gear-driven. In fact, we are going to give this one clearly to the gear-driven advantage on edge work. Although we have to say that our BigFoot random orbitals do edge work very well. But as Todd mentioned, the way to get the best performance with a large orbit random orbital polisher like our BigFoot Mini, you would downsize the pad to our 3-inch pad and to get into that edge work more efficiently using that type of movement. So our peak performance adjustment tips for gear-driven orbital, you simply use the pad's outer edge. As Fabrizio mentioned, you tilt into that edge work and use the action of the outer edge of this pad, and it does fantastic edge work without a lot of technique development. It's actually pretty easy. You tilt in and do it. The random orbitals do edge work very well. It's a little more technique dependent, but as Todd mentioned, you downsize the tool, downsize the pad, and that makes it a lot easier for you to do edge work with a random orbital. Fantastic. So we'll go from edge work to safety. Todd was mentioning safety earlier, so let's go back to him and talk about safety with the random orbital.
The video that's playing on the screen, Jason, you can see that we're actually purposely coming off the edge and polishing the edge itself. Now, the disclaimer is we would never recommend this in normal polishing. It is the highest risk movement you can make. And we're not paying attention to the angle of rotation of the pad. We're simply placing it on the edge, doing really the dumbest thing we can do and not damaging the panel. And that's one of the most important benefits of using a random orbital polisher or the BigFoot random orbital polishing system. The idea that the pad stalls is a built-in safety feature. When the resistance becomes too much to the pad where you would have a dig or a burn, the pad simply stops rotating. So that's an incredible safety feature. Also, the dynamics of a random orbital polisher, the fact that the pad velocity is slower but more even across the face of the pad, allows us to polish a surface with less temperature increase. So this combination of a self-stalling pad to prevent strike-through and edge damage, plus a lower rotational velocity, which means less heat transferred to the paint, which means less chance for thermal damage or on fresh paints, twisting it off. You really have an incredibly safe polishing option, and probably out of the machine polishing options, and not even probably, for sure, out of the machine polishing options, the random orbital polisher is the safest.
Very good explanation about safety for random orbital. Let's hear from Team Gear Driven about safety.
Yes, Jason, it's very simple. Gear-driven polishing is safer than most of the traditional polishing systems. Of course, we have a dominant movement, which is the rotation that the random orbital doesn't have or can be stalled, and so it can reduce the danger. But nevertheless, the rotation of a gear-driven machine is much slower than the rotation of a rotary. We are talking about 500, in our case 535 for our Mille machine, against 1,000 or even 1,500 or even more in a standard polishing rotary machine. So is it safe? Is it 100% safe? No, of course, a gear-driven machine is not, but no machine, no polishing machine is 100% safe. You have to be careful. You have to always take care and stay away from the very edge of the panels. Try to avoid to insist in delicate areas, but you can do that with gear-driven. A little bit of technique might help you to get a better safety on working on those areas. But totally compared to a standard rotary machine, a gear-driven is way much faster and safer, sorry.
Very good, yeah. So in conclusion on this topic about safety, I think we can agree that both are safer tools than other alternative ways of polishing paint. So they're both pretty safe. However, the advantage is going to go to the random orbital because of that feature, again, of the random rotation and the ability of the rotation to stall, which is fascinating to me because it is the strongest safety feature built into all random orbital polishers. However, on Facebook groups and comments on social media, we hear people saying that is the reason why I don't use that tool, is because it stalls. But it happens to be one of the strongest safety features built in to all random orbitals. So here is our peak performance adjustment tip for these tools. For the gear-driven orbital tool, the suggestion we have for added safety is we actually, unique to this category, RUPES offers in the Mille gear-driven orbital the ability to change out the backing plate diameter. In fact, when you buy the tool, you get both backing plate diameters. So our suggestion here is to go to the smaller diameter, the 5-inch diameter, and that allows you less pad drag and the ability to do edge work even better and safer. So the other tip for random orbital, basically a very, very safe tool. However, one potential risk for safety is a side impact. It's such a very tall orbit, so that orbit swinging that pad in a big orbital pattern, there is a slight risk of hitting antenna posts or body parts or perpendicular panels with a side impact. Now we help you with this by the additional foam that goes beyond the backing plate. It's our safety bumper. So we kind of manage that risk very well. But that is one of the safety tips for random orbitals, especially large orbit. All right. Winding down from safety, we look at our last performance parameter that we're presenting to you, and that is learning curve. Simply put, this means how long does it take for us to feel confident, for us to get great results with these individual tools. So we will start with Todd and Team Random Orbital.
Thank you, Jason. And as this is the last silo that I will be addressing directly, I wanted to thank everybody at home for watching before they silence me for the last time. And then, of course, thank my colleague Fabrizio for a wonderful debate. I've certainly enjoyed it so far. When it comes to learning curve, I think the most important factor to consider is how safe is the tool to learn. What you might hear is that the random orbital has such a high potential that it takes a very long time to master. And that's true, but that shouldn't be held against the random orbital. The fact that so many people get such amazing results after years of using it is not a knock on how easy it is to learn right away. And what makes it really easy to learn is how safe it is. You almost immediately eliminate swirl marks. You greatly reduce the risk of burning an edge. You can float it off a panel any way you wish. And so this ability to set this tool in somebody's hands who's never polished any vehicle before and simply instruct them that they have to learn to keep the pad flat, which does take some practice and time, but they can do it in such a safe manner that I really can't imagine an easier and better tool to learn on than the BigFoot Random Orbital.
Excellent, Todd. And we will go to Fabrizio to talk about the learning curve with gear-driven orbital.
Yeah, thank you. Can I say honestly that a random orbital machine is hard to learn? No, I cannot say that. It's fairly easy. You don't need to know much. There are 4 or 5 rules that you need to master to be able to use a random orbital machine efficiently. How many rules do I need with a gear-driven machine? I would say probably none. I can take the machine, I can grab the machine, start working, and it's very hard for me not to get a good result. So that's the big advantage. That's another big advantage of this machine. I don't need to be educated to be able. Can I improve my quality by knowing some tricks? Of course I can. I can improve the quality, I can improve the cut speed, I can improve the quality of the finish, but still, even if I don't know anything, I will get a good result, I will make a good job. And that's the important thing with this machine. Before going back the line to Jason, I would like to thank all of you, to thank, of course, Todd for facing me today and for the big job he did. He did this, by the way. The background is his job. Thank you, Jason, for mastering the meeting so well. And thank you, Dylan, for helping us on creating everything today. Bye-bye.
All right, so we've heard from the Team Gear-Driven Orbital, we've heard from Team Random Orbital, and I also applaud you guys. Thank you so much for the great job. Now, on this particular learning curve criteria, we have a designated winner of this debate, and that would be the Gear-Driven Orbital. And it's simply because of the engineering in the Gear-Driven Orbital tool. The user simply pulls the trigger, applies this movement to the paint, and there's not a lot of information and technique they need to learn to get a decent result. Now, having said that, as these technicians have expressed to you, the learning curve for Random Orbital is not very long, and relative to other alternative methods, it's actually pretty easy for many people to learn. But there is one thing you do need to figure out with the BigFoot Random Orbital, and that is to manage that free spinning rotation. So it is one thing you got to learn. Now, our peak performance adjustment tip for the gear-driven orbital is to simply use the smaller backing plate here, and that will be easier to learn than a bigger backing plate, which is true of all tools with a force rotation. So any tool that has a force rotation, the bigger the pad diameter, the harder it will be to learn that, because you're going to be fighting surface area on the pad. So the smaller diameter, easier to learn, work yourself up to bigger pads. Now, the learning curve tip for Random Orbital is simply from the very start, learn how to apply this polisher to the paint surface with a flat pad to the surface. That is one of the things we observe on people that are brand new to Random Orbital polishing, that tendency to want to tilt the pad into the paint. But if you learn this one tip early on, it'll help with your performance as you develop your skills. Keep the pad flat. All right. To summarize, and we're wrapping up our topic here, we will summarize this side-by-side debate and comparison we'll go through these really quick. We gave a slight, and I'm talking about a very slight advantage to the gear-driven. And a reminder, this advantage is based on the average user. Once again, we have to say, Random-orbital has extreme strong cutting power, but it is a variable based on your experience and your skills with using a large orbit random-orbital tool like BigFoot. Both cutting tools, the comments that you might have heard or said about Random-orbital just being a finishing tool, simply not factually correct. It is not correct. Crazy cutting tool. Both of these are cutters. And on the finishing side, we give a slight advantage to the Random-orbital because of that safety feature built in with the free spinning rotation. The efficiency, we gave that to Random-orbital as well because it has that highest potential for one-step paint correction across a wide variety of paint hardness. The gear-driven orbital is very efficient, but when you get into soft paint, it can actually be too aggressive on that delicate paint. Edge work. We gave a clear advantage to the gear-driven simply by using the outside of the pad. Oops, sorry. Outside of the pad. Then you have this big advantage tilting into the edge. The gear-driven does that very easy and without a lot of technique. Safety, because of, again, the free spinning rotation, the Random-orbital has an edge on safety. It's simply safer to use on all parts, curves and contours and flat spot of the car. Learning curve, we gave that to Team Gear-Driven Orbital simply because you pull the trigger and the tool makes the movement. You don't have to think about the movement. You just move the tool across the car and it does a fantastic job. So there you are, a complete summary. And the ultimate conclusion about this debate between these two tools is that it really depends on your preferences on these individual 6 performance criteria that we've looked at here. So if one of these is a higher value to you than the other, you're going to be swayed over to one tool or the other. So again, our objective is to educate you on what these tools can do and what their strengths are so that you can make an educated decision on which tool is best for you. The final comment we want to make about this is we can't talk about the performance of these tools without discussing what we call the great equalizers. What we mean by this is these are things that you as the user can do regardless of what tool you're using that will get you the best results that you want and expect. So first to talk about as a great equalizer is getting proper training. Get high quality training from a training professional and seek the knowledge and the information from the manufacturer who is the most knowledgeable of their own tool. So get high quality training, learn about this particular polisher that you have in your hands and learn how to maximize your performance. Take advantage of the knowledge on the RUPES YouTube website or YouTube channel, and then also the RUPES websites. There's lots of fantastic information that you can learn how to better apply these polishing systems. Now, the other thing to talk about, speaking of system, is the best one for you right there, your best polishing system is the one that you prefer and the one that you have learned how to use the best and get the best results. So ultimately, that is the bottom line to this whole topic, is what's best for you is the one that you prefer and the one that you have figured out how to get the best results. Finally, our last great equalizer is to simply think of these polishing tools not as a tool. Think of them as a system. So there are 4 things that creates the result that you get when you machine polish paint. There is the tool, there is a compound, there is a pad, and there is a user, there's you. So those 4 things create this result. Many people don't think of it this way, but RUPES has actually done a fantastic, amazing job as a company to science out the synergies between these components that create the result. So these compounds you see on your screen and the pads you see on your screen, those are formulated, designed, and created by RUPES. They are manufactured internally by RUPES. And we have validated the combination of what those components can do to get the desired result. So the peak performance that we promise you is based on using those components that we have made sure work together to give you the best results. So that is the great equalizer tip we have for you. Regardless of what tool you use, please do think of it as a system approach, because there are all these components that work together to get that result. Our system actually is color coordinated. Blue is our kind of aggressive step, but still capable of one step finishing. And yellow is our mid-tier, also capable of one step correction. The red cap and the white bottles is our Uno brand. There are products there. They are finishing products. So this is how our system works. With that, that concludes our content. I invite you to take a screenshot or use your camera on your phone, capture this information. This is how you can reach us. This is how you can engage with our company. On the right side is all the touch points for RUPES USA. On the left side, all the touch points for the rest of the world. So these are different ways that you can reach out to RUPES and talk to us, and we can help you out. I do want to point out our YouTube channel is global. So we have pumped a lot of great, fantastic content in our YouTube channel. Also want to remind you that we have a phone app. The RUPES Paint Correction app is available to you at this moment. You could scan that QR code. That will take you to a link to download the app on your phone. Has a lot of fantastic suggestions and quick tips on combinations based on different scenarios. And it is updated for our new products. So there you go. Use the app. It helps you out. With that, we want to end with some questions. And I'll ask Dylan to help us with this part. Maybe there's 3 or 4 questions that we can
actually
answer.
a lot of questions that had some overlap. And thank you guys all. We've gotten a lot of comments as well. Share with you guys that everybody loves the core series. Johan just said the core series gets better every time I watch. Thanks for sharing all this information. So thank you to everybody who participated, and those of you who didn't ask a question, just wanted to tell us good job. Thank you. We're glad you're enjoying all this. It's a team effort, and everybody on this and a lot of people behind the scenes help us pull these webinars off. So I'm glad you guys are enjoying it. We had a lot of questions associated with the consumables, though. So I think maybe this is a good chance to talk a little bit about the pad compatibility between both systems now that we're on the DA system. I have sent a few of you guys a link to a YouTube video on our channel about the new DA system and the compatibility, but does anybody on the team here want to just make a quick statement, kind of summarize that the DA system is for both tools now?
Yeah, okay, Fabrizio, you want to take that one?
Yes, basically we are facing 2 tools which are very different, but they have one thing in common. They are both dual action movements. It means we always have the combination of rotary rotation and orbit. The difference is how these 2 are combined, but they always have these 2 movements. So that's why our idea has been, okay, let's try to reduce the total number of part numbers that we have in our catalog to make it easier for the end user, because even though we have 2 different movements, but the common thing that they are dual action have allowed us to make dual action consumables, dual action fine and coarse compounds, dual action foam pads and wool pads. So that's why our decision has been, okay, let's simplify everything and let's give to our fellow customers the best possible options in terms of technical performance, but also of easy of use.
Yeah, very well said. The one thing I would add is if you look at the contrast to the rotary tool and our rotary system, if we could, and we actually attempted, if we could have one pad system for all of our polishing tools, we would do it. But the reality of the dual action orbital movements and the comparison to the rotary movement is that they are drastically different movements, and the impact on the paint is very, very different. So you'll find that our rotary system actually has its own formulas of compounds and its own pad designs with its own foam materials that are very different than our dual action orbital products. Again, if we could, we would make it even simpler, but the reality of these movements means that to optimize performance, we need to have certain products for certain tool movements. So hopefully, Dylan, that answered that question.
Yeah, I think that definitely covers it. Tied to the consumable thing, somebody had an interesting question. We didn't touch on this specifically, but I think maybe we could cover this pretty quickly. They want to know why they've heard recommendations that never to use microfiber pads with the Mille. And they would like to know why specifically, what horrible thing will happen if they use a microfiber pad on the Mille, and why is it okay to use it on the Random Orbital but not on the Mille?
Excellent. Yeah, I would like to answer this one. I have a little bit of experience with microfiber pads. But there's the reason we recommend this, and by the way, it's different for us than our competitor and other brands. But here's the reason why we say do not use microfiber pads on actually any tool that has a force rotation or a predictable pattern. So we isolate microfiber pads to random orbitals because of its random movement. So I want you to think about microfiber as the strongest material in terms of cutting, and then you combine that with a predictable movement like a rotation. That means that that cut is going around and round in the same space, in the same circle, and it will make a mark. So it also, microfiber has the characteristic of being the hottest temperature between the pad material and the paint surface. So when you apply microfiber material to force rotation tools, the temperature ramps up very, very quickly. And some of the techniques we recommend in terms of pressure, if you combine them with a microfiber pad, that temperature can ramp up like really, really super fast. So it is actually for the safety of the paint, and it is for better finishing that we recommend you do not apply microfiber pads with a rotary or the Mille Gear-Driven because of that predictable force pattern. And the best performance, all things considered, is with the BigFoot Random Orbital.
Great answer, and I'll do one more. Somebody actually had a question. This is something that came up in the 5 Myths webinar. They asked this during the safety segment, and their concern is a little bit tied to the amount of heat generated with heavy pressure on the Mille. What's the safe temperature range to operate in, before they should be concerned with that heavy cutting approach using a Mille?
So, Dylan, is the question about the surface temperature?
Yeah, surface temperature. So I've already explained to them that radiant heat and frictional heat are two different things, but maybe you should explain that to the audience. But then kind of where is the danger zone? Where does it start? Where they could kind of maybe be a little bit more cautious? Yeah,
so I want you to pay attention to this answer, everyone, because when we think about surface temperature, we have to factor in friction. So the answer involves an answer that involves both temperature and friction. Because the reality is you can take a black car and put it in midday summer sun, and you will reach temperatures of 200, 250 degrees Fahrenheit. What that is in Celsius, I don't know. But over 200 degrees Fahrenheit just with the car sitting there, having surface temperature in excess of 200 degrees. However, the recommendation here is while you're machine polishing, pad to paint, in other words, applying friction frictional heat, 180 degrees Fahrenheit. That temperature sustained with the friction, if you continued to operate at that level, you will run the risk of damaging the paint. You can actually delaminate layers, you can rotate clear coat, you can burn through, cut through. So 180 degrees Fahrenheit with sustained friction can do that damage. So that's kind of the, the magic point. And if you're using the infrared temperature guns, you can kind of learn what that level is for you based on the tool and the pad that you're using at that particular day.
Jason, just for the non-American who are watching, 180 Fahrenheit is roughly 80 degrees Celsius. So that's the limit, as Jason said.
Okay, thank you so much.
That's why I was with a mobile phone, because I was checking, because I don't even know what is 180 Fahrenheit. I have no idea.
All right. Well, on that, if you guys have any parting comments, we're coming up on right about exactly an hour. For any of you who didn't get an answer to your question, either typed in by me or by the team, certainly go to the RUPES.com website, hit the contact us page. You can email us additional questions. One of us on this panel will most likely answer the question for you, or a member of our team will. But anything from you guys before we shut the broadcast down?
No, just a final thank you to everyone involved on the presentation side. Also want to thank you, the audience, for taking the time to view our content. This is a free service we provide. We want you to have this knowledge and this education. Thank you, and we'll see you on the next episode of our core series.